Good afternoon, everybody. Today is good to see you, a full packed house. And good to see pipe drivers. I see people that I know, engineers, product managers, even people that's starting their career path in software engineering. So it's good to see like many different people for a topic that we actually talk a lot inside Pipedrive. That's all about microservices. And we talk a lot about it inside Pipedrive because, well, what you will see afterwards, what we actually do. But everything that we build in Pipedrive is in a microservice architecture. And as all companies grow, they all have problems with microservices. Like I go with beers with friends, they complain about their own problems about microservice. Oh, this doesn't scale, or independency between teams, or we don't know what the hell is happening in our services. And as all companies grow, Pipedrive also has its challenges that tries to overcome, and in order to serve better all our clients. And so that's the reason we decided to do a meetup just dedicated to this, that we call Building Microservice at Scale. And I'm just going to really briefly explain what's going to happen. So we're going to have two talks. First is our great Felipe Tavares over here that will speak a little bit about how actually in Pipedrive we deal with microservice observability, which is a really hot topic right now. And also an invited guest, João, over here, technical product owner at Numbers. And he'll talk a bit also about some of the things they do and some of the patterns they actually implemented in their own microservice architecture. That actually then I saw, and some of them we also use as well. So it was also really cool to see like different types of problems. There's similar patterns that end up being reached at the end. And afterwards also, we have Slido, so if you guys want to then make questions at the end, then Natasha, where's Natasha? Oh, Natasha over there, she's a Slido master, so she'll organize all the questions and the Q&A afterwards. So if you want to do the questions, you can use the Slido code, and we'll then address all the questions at the end of each talk. And the talks are important, but this part is also very important. So we're now in the -1 of ideas. So this is my actually second time at this idea. So I have really little clue of where everything is. But we're in -1, where all the auditoriums are. But then we'll go to the best part, which is the first floor, where we have our networking session, where we have a beer keg that we actually have to use. We can't leave it there. So I'll need all your guys' help. And we have pizza as well. So it's already arriving. They're putting everything there. And, well, there's an amazing rooftop there for the people that don't know the place. So you'll have the opportunity. And at Pipedrive, we actually talk about a lot of engineering, and a lot of initiatives actually are engineering driven. But something that actually is very dear to us, and we like to talk about Pipedrive, is actually our culture itself. And I wanted to showcase one of actually our parties, which one of favorite ones, which was what we nicknamed Summer Garage, which was our summer party. We also work, by the way. So this was just a really little glimpse. Now I want to welcome my great friend. So I just want to introduce the first speaker, Filipe Tavares. Let's go, man.
Okay, so no pressure for me. I'll be a little bit nervous, so if my voice just trembles, like, it's okay, it's normal. So first of all, I want to start by speaking about microservices, observability. I'll talk about a little bit of a journey of Pipedrive. Then I'll jump into like, what exactly do we do in Pipedrive? How do we work in terms of engineering and some of the numbers behind our engineering. And after that, I will talk about like some of the concepts of observability, why we should take observability in the first place, what are the benefits behind it, and some of the patterns that we should take into consideration. And I will also provide some of the examples that we use inside Pipedrive. So first of all, Pipedrive. What is Pipedrive? Pipedrive is a cloud software as a service platform, and our objective is to help our customers to close deals faster. So we don't only provide tools for them to track their deals, but other platforms and tools in order to help them guide their sales. By the way, you can create a trial account in Pipedrive. It's free. You don't need to use your credit card, so it's safe. And you can also understand what exactly we are building behind the scenes, behind just what we do in Pipedrive in terms of engineering. Okay, regarding Pipedrive journey. Next. So where this started? So Pipedrive started in Estonia. It was built by 5 Estonian guys. And currently we are spread across 10 locations. So we are located in Tallinn, in Tartu, in Lisbon, Prague, Dublin, Florida, New York, Berlin, and Dublin. I think I didn't forget about any of them. And probably somewhere other place in the future. So right now, we reached the milestone of 100,000 customers. That doesn't mean end users. So a customer inside Pipedrive can mean from 1 user to 100 to 1,000 users. So our spread is enormous right now. And we are currently serving around 170 countries around the globe. So Pipedrive reached Lisbon in 2017 with 1 person, and currently we're around 200 and something. I don't even remember the exact numbers. We accumulated around 90 million in private funding, and we reached a unicorn status in 2020 when we were acquired at an estimation value of $1.5 billion. So right now, we are more than 100 customers, reached this milestone this year, and we have a multicultural environment where we have people from more than 30 countries. Next. So in terms of engineering numbers, please. So engineering numbers, Pipedrive engineering, all engineering roles are made of 100% of the company, and 1/3 of the company is made of software developers. So this means that we are currently and deeply investing in production and building the platform that we are selling for our customers. In Lisbon right now we are 36 engineers, and we serve 5 different tribes. Some more numbers. So we are deploying to 6 different regions. 5 of them are customer regions, and 1 of them is internal management for Pipedrive. We currently have more than 700 unique microservices, and we scale them for around 30,000 containers. And regarding deployments, we do more than 150 deployments per day. And if you multiply this by the number of regions that we have, we can reach up to 1,000 deployments per day, which is a great number for our numbers. Our infrastructure is served with around 31,000 CPUs, 90 terabytes of RAM, and we are serving around 350 million public API requests per day. And we also have a mix of private and public cloud. And probably we are deeply investigating where we should go next. This is our stack. It's not all, but some of them. So from Node.js with TypeScript, React, GraphQL, MySQL, Rabbit, Kafka, PHP, Golang, Redis, Docker, Kubernetes. So a lot of tools that we have that we need to take into account, and we need to observe them. Because it's not only about providing tools, but we need to provide a way of observing them and figure out what's happening with them. So in terms of Pipedrive Agile framework, so next, please. So as I talked before, I've probably said the word tribe for like 2 times, and you might think, oh, what's a tribe? So in Pipedrive, we work differently than the usual. So instead of working with teams, we work within a tribe. And a tribe is responsible for a specific use case or a specific business goal, okay? So this tribe is supposed to be autonomous and should have ownership of the full software development's life cycle, from strategy to maintenance. And this is a lot of things to take into account, but how do we do it? So in a tribe, we have every role that we need to have in order to provide the entire full cycle. So we have developers, we have product managers, we have designers, we have analysts, researchers, and every other role that can be multidisciplinary within the company itself that will help us reach our business goals. So by having this tribe that has the full responsibility of a domain, we also have our ways of working. So every time can follow some standards within the company itself, but they are open and they are free to create their own ways of working. And this is also helps because you can't go into Lisbon and say, okay, you need to work like this, and go to exact same place, go to Estonia and apply the same ways of working, because culturally we are different. We might share some of the main core ideas, but we work differently, so we need to adapt, and that's why we are open for it. And feedback is one of the most important things that we have in Pipedrive in order to provide it. Next, please. And wait a little bit more. And if you want to read more about this, you have a great article written by our former CTO, Sergey, which is on our Medium engineering blog, which is called Scaling Pipedrive Engineering from Teams to Tribes. So now, before I talk about microservice observability, microservice is just a prefix of the word observability, because observability, you can put it in whatever you want. You can put it in your daily life, in wherever you want to observe, actually. But before I deep dive into microservice observability, I would like to give you a use case or a real life use case, a simplified one for sake of understanding. So let's give this example. So we have a product, doesn't matter the product that we have, and our users are reporting an issue because our system is behaving. So typically, what happens in a software development company, depending on the process that you'll have someone that is on call, right? And this person is responsible for understanding what's happening with our product, is misbehaving, and maybe some hours later, this guy is deep diving in logs, in information, and he will, okay, I know what the problem is, and he identifies the problem. So he identifies a bug. He took some time to do it. It took probably some hours. And after the problem is identified, he's quickly able to fix the problem. So from identifying the problem is usually a short time span, right? And then the problem is fixed and everyone is back to normal and we are happy again, right? But in this use case, we have at least 3 problems. So one of them is you don't want never the problems to be identified by your customer. And this usually happens when you are not observing what's happening. Then we have another problem. So we have a person that is usually on call, and this guy will receive a lot of pressure because he has 30 tools, he has so many information to dig in, and we, as a company that are building a product, we are not helping him to identify the problem quickly. And if he's not able to identify the problem quickly, it means that the users will perceive this issue for longer because the problem will only be identified way longer than it should. Okay? So this is the context of observability. If we are, can you switch? Yeah. So what is observability in the end? So next. So observability is a superset of monitoring. But the thing is, with monitoring, we are reactive. It means that we are only notified when something is already wrong. And it just says that it's wrong. It's not says why. So observability is the key for us to ask why. Why is this problem happening? So we can look at different symptoms to identify a root cause. But if you are just alerting, oh, your system is not healthy, it doesn't give you enough information to you reduce the time to detect an issue and where it is. So observability will provide you granular insights into implicit failures, but not only. It possibly give you more information about how high-level overview of the system's health. And depending on the granularity that you want to have, you can also be, those insights can also be low level. So if you set up your observability correctly, you'll create a context to understand how your system works. And it will enable you to discover deeper issues that you would never be able to detect without it. So in terms of observability, there are 3 pillars regarding it. One of them is metrics, which will help us to detect real-time issues, and by collecting those real-time issues, like real-time metrics, will also enable us to store them for longer times, so we can understand historically what's been happening with our application. There might be metrics that you record for years, there are metrics that you record for weeks, and metrics that you record for months. They will depend on the use case. Logs. Logs is probably the first thing that you will search when you're having a problem, because logs will provide you the exact understanding of why the problem is happening in the first place. So usually when you are creating logs in your apps, you are including stack traces. So you can jump directly to your code, exactly find out where the code is broken, where the app is broken. And not least, late but not least, is tracing. So tracing will help us locate the problem in exact specific place. It will help us understand all the dependencies that we have in our applications, how they communicate, etc. So I'll talk a little bit more about some of the challenges that we have with observability, because it's not only good things. It's like you need to think through before you implement them. So one of the challenges that we have with microservices architecture is communication and also related dependencies. So within a microservices architecture, it's normal that the number of services and microservices that you are releasing is higher. This means that you will create more dependencies. So it's normal that one API call will turn into multiple API calls within your system. And this creates one problem, is because you have a lot of dependencies, you'll have a lot of services, and if you are using tools to implement observability strategy, it means that you need to manage all those services, so you need to update dependencies on all of those services. So when you're thinking about observability, you need to think through exactly what you need to implement in order to lower the maintenance cost of those services and the observability stack itself. Another one is multi-language. So like I said, Pipedrive is currently supporting, I think, 4 languages: PHP, Node.js, Golang, and that's it. Yeah. And but basically, when we are creating a framework for observability, we wanted to keep it standard. Because imagine having this scenario where you have multiple languages reporting observability for different tools. This means that your observability will be spread across multiple platforms. So you need to not only account that observability will be spread across multiple platforms, which you don't want, but you also need to think about that you need to maintain the libraries in all of those languages. So the volume. So like I said, there are metrics that you want to keep for longer, metrics that you want to keep for a shorter period of time. But the more you want to collect, the more you want to observe, the higher the cost will be. So you need to really think through what exactly do you want to measure and what exactly do you want to track. And another one is software as a service. So as software as a service is growing so much, we have some challenge with it. These are becoming multi-tenancy, where before we were creating products on premises. Now we are creating on the cloud. We are creating multi-tenant products. And as we want to serve our customers geographically where they are, it means that we are creating multiple regions environments. So if we are multi-tenant and multi-region, it means that we will have our information scattered along the globe, right? So we need somewhere in a single place to look for everything that is going on, because you don't have to be creating platforms for dedicated regions, because you want to be agile. So if you want to add a new data center in, I don't know, in Australia, you want to be directly connected to the tools that you already have. So you need to be agile in when you pick the tools that you want to observe. So we were monitoring, so we were asking exactly the same question over and over again. And these, although it's useful monitoring, without observability, without the metrics that we can provide observability, the questions that we can ask with the monitoring are limited. So that's why when we talk about observability, we think about the visibility. What information do we want to provide to be able to collect metrics and to set up alerts based on it? So, as I said, monitoring is reactive, so the problem has already happened. And if the problem already happened, it's probably your customers already noticed. So when we start moving from reactiveness to proactiveness, we'll start gathering metrics along the time. This way will mean that we'll be able to predict exactly what's going on with our app. And it does not only allow us to predict what's going on with our app, it will also provides the answers. How will my product behave in the future? Because if I'm growing, I know how it will behave as well. So by having these three topics above, this will also improve our developers and our customers' confidence. Because in a microservices architecture, you are deploying more than you were used to. And if your developers know that your app is being tracked, you have visibility over it, you have alerts set up, you're deploying with more confidence, and this means probably the number of deployments with an observability setup will increase as well. But it's not only developers' confidence that will increase, it's your customers as well. Because customers will perceive less incidents because you already predict them that they are going to happen. When I started this microservice observability, I also started with there's a problem within when the problem was detected until it was raised by our users and detected in terms of what's the exact issue. So one of the objectives of observability is to reduce the mean time to detection. And you slide to the next slide. So when you're talking about mean time to detection and mean time to repair, the failure happened. There's the detection and the resolution. So between the detection and the resolution, this is usually really quick because you already understand what the problem is and what the fix should be. So it's a matter of how agile your deployment structure is. That's here where the problem always usually reside, and that's where observability will make your stack more compliant with what we want to implement. So I talk about all the benefits, why we need observability. Now I'll talk a little bit about the patterns that you should take into consideration. So one of them is health check, logging, application metrics, and distributed tracing. I'll talk briefly about every one of them and also give some examples. So with health check patterns, so in a microservice architecture, your services are communicating with each other. You probably have an API gateway that is serving customer requests. They'll probably route requests from an endpoint to a specific service. But your service is probably scaled to multiple instances because you want to provide scalability and you also want to provide redundancy. So your service discovery tool or service registry should be able to understand if your service is healthy. So this endpoint, which we call health check endpoint, is usually called periodically to understand if your service is healthy. And what does this mean? So if your service is depending on multiple infrastructure, like for example, Rabbit, MySQL, Kafka, other service, you want to perform all those checks before you're saying that your service is ready. Otherwise, your request might be failing. You can go next. So this is one example. Like we use Console as our service discovery tool, and this is just an example of the health checks are passing when we are referring to PHP. So we have PHP service with all the containers that are running PHP, and each endpoint of each individual container will be called and say, okay, I'm healthy or not. So what about logging? Next. So logging is, like I said, is probably the first place to start regarding discovering what's happening in your app. And you should always take in consideration that your product is not only about the service that you provide, not the number of containers that you provide, but also the infrastructure. So you should also take in consideration that your service is accumulation of the loggings of the service that you build, that you have, but also the infrastructure that you are supporting your microservice architecture. And like I said, with the microservice infrastructure, everything will be scattered. So you have a bunch of services, a bunch of regions. So you probably want to have some kind of logging pipeline. So you can also probably sometimes, for example, for GDPR compliance, you want to mask what's being logged. And probably will end up a logging servers where information should be searchable and analyzable, because in the end, it's all about the user experience of the person that wants to sit down, has a problem, and okay, where the problem is, and it needs to be easy for him to jump quickly on what's the problem. Next. So this is just an example. So currently we in Pipedrive, we are using Graylog, and basically you can search for everything like, oh, give me the logs for this facility or service or container and the errors, so you can actually jump through and actually understand exactly what's the trace of the error that's happening. So in this case, like, it's easily understandable that this is a connection refuse by the service itself. So what about application metrics? Application metrics don't mix the name of application with the actual app, with the actual service, because application metrics is way more than the service metrics. It's also your infrastructure metrics and your system metrics. So some example of system metrics that we can provide to our metric server. We can provide CPU, memory, like garbage collector time, I don't know, whatever you want, network. So everything that you want to collect, you can use it like a library tool for collecting metrics regarding the system where your service is running. And you can have two different types of metric ingestion. So you can have pull-based, depending on the type of metrics that you want to collect, or you can also have push-based, which is your services providing the metrics proactively. So, and then you have application metrics. This is usually when we need to think more on what we want to provide, because the use case will be different depending on the service, depend on what exactly you are building. So for example, just some metrics that you usually take in consideration is the request per second, per endpoint, per method, the error rate for each endpoint, duration of each request. So this is like the kind of metrics that probably we want to store for longer periods of time. Because imagine a scenario like Pipedrive, which has 12 years. So we have been growing for a long time. And we have a monolith called PHP. And PHP, some time ago, used to perform at a certain level. And we want to track that metric along the time. Because that's why we need to understand where we are going. Because if we jump 1 year back, where were we at? So there are kind of metrics that you want to store for long periods of time, and others that will be shorter. So this is just one example. Like we have Grafana as our query tool. So we have a dashboard for HTTP requests where we have multiple regions within the same dashboard, specifying different service names, being able to specify routes, and also, for example, to show deployments, which I will show you in later slides. But this is just an example of the granularity that we want to have and the information that you want to collect. So it's really flexible. You just need to think through exactly what you want to collect. But I just want to phrase something is like, if you want to provide this kind of functionality and you are building 700 services, you need to standardize. Otherwise, your metrics won't value nothing because you are in a company. Multiple companies will try to, or different teams will try to implement stuff differently, and that will not be able to correlate data. So you want to create standards within the company, your product, in order to be able for that information to be valuable. Next. Then distributed tracing. So like I said, distributed tracing, so it means that with the microservice architecture, one API call can lead to multiple API calls. And this can become a problem in terms of debugging a problem, like what exactly is taking more time. So we need a way of understanding what exactly is taking long. And distributed tracing is how we can granularly provide the ability to track flows within your application, within your service, within the transaction. And how do we do it? So there should be a unique identifier that will be passed throughout your services. That's how you are able to collect the correlation between all the requests that are being made through a single API call. And it's the best way to detect what's going on with your application. So this is just an example. So we have, let's imagine we have here an API service that is receiving a request, and this service is making requests to service B, and service B is making requests to service D, and service D, and also called service E. And when we start implementing distributed tracing, we'll start getting stuff like this. So we have an entire trace, which is the amount of all the spans that are included within a trace. So each span is the individual trace within the service call that was made. So this way we can understand, okay, service B is taking like a long time. So this is how we can get the granularity that we want when finding issues. So about retention, so like I said, there are metrics that you can store for a long time, others for shorter periods of time. So when you think about time, you want to keep your metrics for longer, others for just shorter time. Then you want to collect logs and traces. And if you think through, if you think about storage, this is exactly the exact opposite. So you have a bunch of traces, because traces have more granularity. Then you have logs, and then metrics. So when you are thinking about traces, probably you don't want to have traces for a month. Maybe you just want for 1 day, or 2 days, or a week. But maybe for metrics, you want to have like metrics for a year. So this is like, you need to be able to understand the amount of metrics that you'll have and the amount of storage that you will occupy, so that you can also save costs. And another thing, and probably one of the most important things is like you can build all the tools, provide all the experience that you want in the world, collect all the data, but if the data is not easily accessible, it's not easily accessible, this will be like really hard for people, for users to use, right? Next. So when you are thinking through on adopting an observability stack, you also need to take in consideration that you should also drive the adoption of it, because the adoption is what will bring the benefits. Because you can build the tools, if they are not adopted, those metrics that I've talked to, like reducing mean time to detection, number of incidents that you are putting live, will not have an impact. And all of them should be easy to use. And standardization is key. So it's like you need a way of seeing what's happening in the standardized way. Otherwise, every team in your company will create their own graphs. It will create all those kinds of alerts. And when you start to standardize, you also reduce the amount of work that the teams that are managing their specific product or the specific part of the feature will not, it's not needed, right? So I'll just provide some examples of use cases that we have in Pipedrive and might like bring some inspiration or just like raise some questions or whatever. So this is just an example. So we are using Graylog for logging, and we have some dashboards like to understand like which errors are we having, which warnings are we having, the infos that we are having, the number of services that they are logging. We also have deployments enabled. So basically we add annotations to our dashboards so that we can say, okay, this deployment was made at this time by this person. You can jump to the GitHub commit. You can understand where it's being deployed, because this graph is related to USist, and who deployed was actually me. And also understand, as we are a multi-tenant product, we also have a way of detecting, okay, is this just like a company? What's the cardinality of the metrics that we are receiving? Because if it's just like one company, we can, okay, probably there's a problem with this company, and you can really drill through to this company. And some examples of infrastructure. So we have different data centers, like I said, 5 customer regions. We have a bunch of services, the number of replicas that we have for each one of them, the deployments, like I said, tracking CPU, tracking memory usage, tracking garbage collection duration, and event loop. Like, do we have alerts for everyone? No, because it's like by having data doesn't mean we have to have alerts on everything. Sometimes it's just a symptom, right? So maybe you want to be warned about it, and maybe the next week or later the next day you want to dig into, okay, understand, okay, why this popped was because of the number of requests that were coming or other thing. Next. MySQL, so for example, here we are trying to detect all the queries that we are performing to MySQL, which service is being called, which query is actually being made, an histogram, like a distribution over time, like how many requests are hitting a specific bucket, and also the rate of requests. So for example, here we have the minimum number of requests that we receive and also the max. So for example, here we are receiving 223 requests per second for that specific query. One example with Kafka, for example, here, this is actually an incident that we have. It was not actually caused by our team, and we see that the lag grew up to 60,000 messages. So this is the kind of thing that we want to be warned about. That's why you have the green heart, is because we are like being alert if the lag is growing, because it means that messages are probably not being consumed at the rate that they should. So this is something that we want to be alert on. So this is, for example, an example of how do you track things over time? Because it's not only about collecting metrics right now, it's also collecting metrics now, and how did they compare to the homolog period. So imagine here we are on a Wednesday, in this 2-hour interval, and we have this amount of requests. And if you think through in a product, the product behavior doesn't change drastically over time. So that's why we are tracking the number of events that we receive per region and per entity. And we also have the events received here, omitted, so that we can also have alerts. So this way, this metric doesn't have any variable, because in this Grafana version that we have, it doesn't support having alerts with environment variables. And here we have events received in a homolog period. So we are getting the number of events that we are receiving now, dividing by the offset of 7 days, so that we can get a number of like how much requests are we receiving, so they can say, okay, is the number of requests 1.5 above that we are receiving last week, or 1.5, or like half of the number of requests? Because if so, that means that probably something is happening. So this way, we want to be warned about, not a critical alert, but we want to warn because we need to investigate beyond. Logging, so just like I said, some examples of logging. So we can have different search queries, like specifying the relative time, the facility, the level of the error that we are getting, and also including the stack trace. But one thing that we should have in consideration is, as we talked about, when we have distributed tracing, we need to have something to identify the exact request. So we should have a unique identifier. So press next. So here above we have the correlation ID. So I can easily pick up this ID and go to our APM and search exactly what happened in the entire request since it came to Pipedrive. So it's easy to understand where it passed, which services it responded to, and why this problem actually happened in the first place. So this is just an example of getting traces for all services. Like this is like one request in specific. I just pick up randomly a correlation ID, and as we have different type of interface. So we have HTTP interface, we have message broker interfaces, we have other metrics that are behind the scenes being injected, so we can get a drill down of exactly everything that happened. Next, and here is also another example of understanding exact requests that happen. So some of the APMs are receiving all the traces that we are sending, but they are sampling because the amount of data that would be necessary to store everything would be cumbersome for them. So what they know is like they detect patterns on the traces. So this is the standard. So if something deviates from the standard, like durations, they will actually store it so that you can jump into these slow transactions and you can drill down exactly what was happening. So this is just an example of one of the tools that we have. So another thing that I talked to is with these software as a service, multi-tenancy, multi-region, we also have high cardinality metrics. So for example, in Pipedrive, like I said, we have 100,000 customers, and we are talking about customers, not end users. And if every single services were reporting all the metrics specifically for a specific company or specific customer, it would be impossible. So that's where transactions and distributed tracing come in place, because you store them for a shorter period of time. So that's why you can answer questions like, what's the performance of this customer in specific? So if you have, for example, we have sharded databases for all our customers. So you can, not every customer will perceive the same speed. So you can also answer questions like that. So, okay, give me the top 20 customers and what's their current average response time. And also took a liberty to specify like some lessons learned from this. So one of them is never hear that your service is broken from your customers, because this will break the confidence on your product. And this is important. This is not about software development. This is about product development. Also, you can only track what you have usability over. That's it. If you don't, and this can apply for everything. It's like, oh, you want to lose weight. If you are not tracking, you don't know that you are losing weight. So if you don't know where to go, you'll never ever have nothing. Next. And you also need to know your limits. So for example, Pipedrive is scaling, and it's normal that as the number of companies is growing, performance is always changing. So by having metrics over time, you'll be able to detect where you are going and exactly where your limits can be. And automate wherever you can. So there are probably some alerts that you can auto-remediate. For example, you have 0 service healthy. Maybe you can automate, you can restart service, you can do something proactively and try to remediate the issue. But if it doesn't, it can alert you like something is wrong. And this also applies when you are, for example, deploying a new region. You are deploying a new data center somewhere. You want to this task to be without cost, without persons, without people. And this is currently our observability stack. So we are using almost the entire Grafana stack. We are also using OpsGenie as our alerting tool, New Relic as our APM, and we are currently changing to OpenTelemetry. And as this talk was not only produced by me, I also got inspiration from these articles. Maybe you want to read them and also get to know a little bit more. And that's it. Questions?
Okay, after this great presentation, I feel a bit pressure. Mine is a bit smaller, so I was invited here by the guys from Pipedrive to speak a bit microservices. I didn't want to make something too big, so I decided just to bring a specific pattern that we implemented more or less recently. So the agenda here will be a bit about numbers and me, then what was the problem and how did we solve it, and then Q&A. Okay, so first about our product. We have an HR and payroll process, so it's a bit similar. Also a SaaS cloud platform. Some of our core objectives is to make it easy to connect. So we invest a lot in our API. We have more than 100 integration with other products, and we also focus a lot on process efficiency. So our goal is to provide the best experience for the employees, and for that we provide a nice software for HR people, for payroll people, so that can help the employees in an easier way. About myself, I'm a technical product owner. My focus in the last years have been the developer experience. It was also briefly touched previous presentation. And then also about architecture and more specifically the microservices and the DevOps culture. So to have an independent teams, also a bit that cycle that was shown in the previous presentation. So that's a bit where I've been focusing the last years. So the problem I bring here is a concrete problem. This really happened. So we had one of our services. In this case, it was a more functional service, let's say. We kind of differentiate the more functional service to the ones that are more core and our platform. And on a subset of requests, in 11 million requests, we saw a huge amount of HTTP calls being made after. And they were mostly concentrated in a very specific core service, or you can also call it like a master data service or core entities or whatever. This was, I think, about employees, because this is one of our core entities. And why was this a problem? So the fact that we have a lot of HTTP hops, it always adds latency. So when we are making a request, you also saw it in the previous presentation, that tracing thing. So you saw all of the impact that each of the HTTP requests puts in the original request. And then also the chain calls problem, which is like you make one call, that call has multiple HTTP dependencies, and then those dependencies also have their own HTTP dependencies. There's also a famous talk about, I think, microservices hell, that it was like they were just making a first call in the old system that took, I don't know how many years to build, and then it just broke down because it was millions of requests all over the place. So this is a bit that, and then the dependencies on other services in terms of failure. So you are making a request, a lot of investment is being done, so multiple services are doing stuff, and then one fails, the whole request fails, and that investment was a bit for nothing. So what we decided to implement for this case, we had this use case that was just a list of things. So in this case, I think it was tasks that have to be performed for employees. And then we had to show the employee name in the list, okay? So the basic approach would be to get this information from the other core services, core service here, right? Getting the names. And of course, we had cache and so on to make it a bit better. But still, that as you saw, even with cache, the amount of HTTP calls that we were still doing. So what we decided to do is to cut that part, and then we are making a replica here in the functional service. So we are keeping the employee basic data there, and we are using events to keep the entities in sync. And this is called event carried state transfer. So basically, using events to carry state to another place. So the name is quite self-explanatory. Some important concepts here about this pattern. So we have to be careful that the consuming service cannot change that data. So that data has to be immutable in that domain. So the only logic that can be applied there has to be the responsibility of the owning service, so the core service. We have always to take into account that the data might be stale, because there's always a time between the time where the data was actually stored in the original service or in the owning service, and then the time that it comes to become in sync in the consuming service. So we have to take that into account. Another thing is the versioning of the events. This is quite useful, because when we are syncing data, it's very relevant, for example, the order that the events have. And the fact that you have versions can allow you to have parallel processing and things like that, that make the process much more efficient. What are the main advantages of this pattern? It makes the service more resilient. So if the core service is having performance issues, if it's down or something like this, then that makes the service much more resilient, the functional service. And then it also improves the performance, because we skip that HTTP call and we can just take the query that we were using, for example, to get the tasks and make a join in the database and get all the data that we need without almost any performance penalty. What it brings negatively, it's much more complex, of course. Syncing data is always a problem. And there's also a minor issue, let's say these days, because storage is so cheap that it brings a little bit more cost there. We also considered having centralized cache, and we are actually using that in other places with Redis. It's what we are using for that. But what was for us some risks that we saw is that for these core entities, there's potentially a lot of data. Then also it becomes a single point of failure. This service is a dependency on many services. So, and this specific data, like the employee names and the employee types and other information, it's really relevant for many services. So the fact that we would have that single point of failure seemed to us as quite a big issue. And then for the lists, that was the case that I was showcasing here, we also saw a lot of complexity there, because in each list we have a different set of employees. So to cache that, it brings also a lot of challenges, because either we have to cache every combination, or then we have to make some logical combinations or things like that, but that also brings some issues with serialization and so on. So that was why we decided not to go for that approach. What we then decided to invest was on the reliability of the syncing mechanism. So that was the part that we saw it had the biggest risk. So we always think, oh, something is going to break and then the data will not be good. It's always better to go to the original service that has the correct data. So we decided, okay, let's invest here. And we decided to first invest on the communication part, and then we implemented the inbox and the outbox pattern. And then we also invested in snapshotting. And the snapshotting basically was to be able to refresh the data from time to time. So even if something would go wrong, we would have a mechanism that would make it simple to refresh the whole data in the consuming service. So I didn't put a lot of detail here. You can always investigate further. But regarding the outbox pattern, what was our main goal was to guarantee the delivery at least once. And we applied we took advantage of the transactions to do that. So basically, it's quite simple. When we are doing these changes in the core service, we do it in the same transaction. We store the event already prepared in the table. And with that, we make sure that the event is there. And it's not going to be like the scenario that, for example, the event broker is having some issues, and then we lose the event or something like this. No. If we apply the changes, we are also going to store the event. If something goes wrong, we just roll back the whole thing. So, and a similar thing we do in the inbox side. Basically, when we are retrieving the event from the event broker, in this case we are using Service Bus, we just store it in a table without processing it, and then we do the processing later in another process. So, and with this, we guarantee that the event was received and it is on the service side already. Then, for the processing, basically what we do, we have an independent processor that is fetching the events from the tables, the outbox or the inbox tables. And then we do the processing, either sending it to the event broker or actually making the changes in the final destination, so putting the data in sync. And only when that is correct, we are changing the state of the event in the DB or deleting the event. I don't remember anymore how we were doing that. Regarding the snapshot, basically, this is like sending a lot of events at once. The main goal of this, like I was telling you, was to provide the option for us to periodically refresh the data. And what we do, basically, we have a process that converts all of the data into events. And then we keep that in a database, a snapshot database. And then we have another process in the consuming service that is fetching those events and is going to consume them in parallel with the regular events. Of course, we have some load control mechanism not to overload the consuming service, but it's still not so bad. I think for this case that we implemented, it was about 12 million events, and it took less than 1 hour to refresh the whole data. This is also quite useful for another relevant thing, which is the initial load. So for the consuming events, it's also important to have the initial load. It's not something that we, let's say, if you want to start using the data, you need to have data there. It's not from the moment that you turn it on that you're going to have the data. So we are using also the snapshots to load the initial data into the consuming service. And another thing that I thought it would be relevant to bring here, it's a bit connected also with one of the slides in the previous presentation, that one with the Swiss Army knife. So if we want people to adopt these things, we have to make it easy for the developers. And this is a bit, in our team, it's a bit our mantra, let's say. We want to make it easy for developers to do a great job. So, and for that, we decided to create packages. We have a package for the publishing services, and basically in the setup of that package, you have basically to say, I want to start publishing events. I say who you are, so what service you are, and then what entities you want to start publishing, and what type of events. For now, we just have these two types, added, change, and deleted. And also, how often do you want your snapshot to be generated? This is for the publishing part. And then for the consuming, I think it's even easier. So you just set up, you install the package, set up, you say basically, I want this and this service. From this and this service, I want this and this entity. And you can also say what properties are you interested in. And if you want also to refresh the data from time to time. And everything happens without the developers needing to do anything. So basically the tables are created, the data is updated, things are processed. You don't have to do anything, everything is done under the water, let's say. And yeah, basically that's it. This is the outcome. So we have the happy developer that now has his service super fast, and he doesn't care when the other services are down. This is like a bit the microservice dreams. Of course, it never happens, but, but yeah, at least for this specific case, it happens. Just a small summary. So this pattern, I think it's quite useful in certain scenarios. And the scenarios that I see it useful is basically when we are thinking about core data or core entities, data that doesn't change that frequently. So if it changes a lot, if it's transactional data, this is not good. It's not like a silver bullet, so you have to consider really if this is the right pattern for the problem that you have at hand. It makes things faster and resilient, but it also adds complexity. So you have to take that into account when you choose to use this pattern. And yeah, that's it.